Hello, I am Madam Gracious Kanzieni from Educare Tanzania. Warmly welcome in our media Educare TZ, so as we can proceed with our A-level tutorials. And here, my students, we have our chemistry subject and our class level is Form 5. As we know that in A-level we have only two classes. We have Form 5 and Form 6. But here, now we are dealing with the tutorial of Form 5 class. And my students, our main consideration in this tutorial is the physical chemistry. We have several topics in the physical chemistry. Mainly for Form 5, there is only 4 subtopic or 4 main topics. You have the concept of gases, we have the concept of relative molecular mass in solution, we have the concept of two-component liquid system, but also we have the concept of energetics. And so wonderful in the concept of gases, we already cover each and everything, but now we are proceeding with the concept of the relative molecular mass in a solution. And for today, my students, we are going to talk about the Van 't Hoff's law of osmotic pressure. Remember, from the beginning, kwenye hii topic tuliona kuna 2 main subtopic, ambapo ni issue of colligative property and the laws which govern the colligative property. So now what are those laws? Na tulisema kwenye colligative property we have 4 main category or 4 main types, ambapo tulikuwa na lowering vapor pressure, the boiling point elevation, freezing point depression and osmotic pressure. So tushaona zile zote issue of lowering vapor pressure, boiling point elevation, freezing point depression, and now we are in the osmotic pressure. Lakini kumbuka kuna hizi laws. Tuliongelea issue ya laws ambazo zina govern this colligative property. Now let us see the Van 't Hoff's law of osmotic pressure. How do this law guide this colligative property aspect or category of osmotic pressure? Now, simply, here we are going to see the quantification of the osmotic pressure on solution. It can be seen from the work of the Dutch chemists Jacobus Henricus van 't Hoff. Huyu ni mtaalam ambaye mwenyewe alikuwa it's from Dutch, alikuwa ni mtaalamu wa chemistry from the Dutch katika mwaka 1852 mpaka 1911. Kumbuka hawa ni wataalam tu, walikuja na idea zao baada ya kuwa proved, wakafanya experiment zikaandikwa, ndio maana tunazisoma. So now ndio maana hata unaona the law known as Van 't Hoff's law. Van 't Hoff's law ina maana jina la mtu. Jina la mtu anaitwa Jacobus Henricus van 't Hoff. Van 't Hoff. So in the law called, sasa yeye alikuja na this work, alikuja na hii concept of the quantification of osmotic pressure, and therefore the law called the Van 't Hoff's law of osmotic pressure. Van 't Hoff, Van 't Hoff's law of osmotic pressure. Ina maana huyu mtaalamu yeye aliangalia quantification of the osmotic pressure on solution. Alikuja na hii concept. Okay, so here we are going to see how do this Van 't Hoff law explain or govern this osmotic pressure. Now we have to know what are the statement of the law, kwamba law ina state vipi, law inasemaje, what are that law. So when we talk about Van 't Hoff law, ina maana gani? What are the general statement toward the law? So simply, the law states that the magnitude of the osmotic pressure is proportional to the number of solute particle present in the given volume of the solution. Kwamba huyu Van 't Hoff yeye alisema kwamba magnitude, ina maana consider magnitude of the osmotic pressure. So the magnitude of osmotic pressure alisema kwamba is proportional, is direct proportional to the number of solute particle to the given volume. Sasa unaweza ukajiongeza kitu kwamba number of solute per given volume, that is molarity. Hiyo ni molarity, unaijua, ulishaisoma kutoka uko kidato cha 3 kwenye mole concept and related calculation. Ulisoma hizo concept kwamba molarity is given by number of mole of maybe solute or solvent over a volume. Kwa hiyo yeye akaja kusema kwamba magnitude of the osmotic pressure is proportional to the number of the solute particle. The number of solute particle mean that we are talking about the number of mole of the solute. Kwamba number of solute particle present lakini pia in a given volume of solution. Kwamba hizo solute, kumbuka solution is made up of two things. We have solvent and solute. Sasa hatuwezi kuwa na solution alafu hatujui solute ndani yake. And that's why we are studying this topic of the relative molecular mass in solution. Ina maana tunaweza tukajua mass of the solute katika nini? Katika solution tofauti tofauti. Okay, so this is how the law states. That is how the law says kwamba magnitude of the osmotic pressure is directly proportional, or you can say either proportional to the number of the particle, number of mole, or the number of solute particle to the given volume, So this statement can be expressed mathematically. Kwamba hii statement inaweza kuwa expressed in mathematical way. So simply mathematically tuna express in this way kwamba this pi, nilikwambia hichi kidude hiki tutakitumia kama osmotic pressure. Kwa hiyo popote utakapokutana nacho, ni kwenye formula, ni kwenye nini, jua kwamba this is osmotic pressure. Lakini kitatumika ni kama osmotic pressure katika this concept only. Ukienda kwenye normal calculation huko ukakutana na hii pi, jua ni ile constant value ambayo inajulikana, ile constant value ya pi. Lakini hapa yes, it look like pi, lakini tunaitumia kama osmotic pressure. Therefore you can see that mathematical osmotic pressure, the magnitude of osmotic pressure is directly proportional, or is proportional to the solute of the particle, or the number of mole of solute to the given volume. Sasa kulingana na hii concept ya number of mole of the solute at a given volume, maana yake kwamba tutakuwa na inversely proportional between the osmotic pressure and volume, lakini pia between this number of mole and the osmotic pressure. Kwa maana yake kwamba the osmotic pressure with the number of mole or the number of solute particle itakuwa ni direct, lakini when we consider the volume, we can see that is inversely proportional. Depending on this ratio between the number of solute over the volume of the solution. So now my students, you can see that the number of particle unit volume is equal to the molarity. Number of particle unit volume is equal to the molarity. Kwa maana yake kwamba tukiwa na number of mole of the solute over the volume of the solution, hiyo tunajua ni nini? Is molarity. Na hiyo ni formula ya molarity ambayo ulishaitumia sana katika kusolve maswali mengi ukiwa katika O level. So utaona kwamba kama n of the solute over volume ni molarity, kwa maana yake kwamba tutasubstitute kwenye ile question yetu. So from there kwenye osmotic pressure is proportion to that of number of solute particle over number of volume of the solution. Instead of writing that, tutaweka capital letter M ambayo ina represent molarity. Therefore simply tutakuja kupata equation hii hapa kwamba this pi is directly proportional to the what? To the molarity ambayo ni capital letter M. Na maana hapa tumereplace ile any solute over V of the solution, tumereplace na hii capital letter M. So simply tunaenda ku remove this alpha sign ambayo ni proportionality sign, tunaenda kuiondoa. Sasa tukiondoa tutaireplace na constant K. Therefore pi, or the osmotic pressure, will be equal to K capital letter M. K capital letter M. This is the mathematical expression of the osmotic pressure depending on the statement of the Van 't Hoff law. Kwa hiyo umeona kwamba ni jinsi gani this law guide this osmotic pressure is the category of the colligative property. So now you can see that where K is the proportionality constant, which is equal to the gas constant, ambayo gas constant inajulikana kama R, times the absolute temperature, that is K ni sawa na RT. Sasa kutoka kwenye hiyo question yetu ambayo osmotic pressure ni sawa na Km, Therefore tunakuja kuinterpret K ni nini, tunaitafsiri, tunaichambua K ni kitu gani. Sasa K tunasema kwamba ni proportionality constant of course, ambayo ni sawasawa na gas constant ambayo ni R times the absolute temperature. Kumbe K ni sawasawa na R mara T. R ni universal gas constant, T ni absolute temperature. Kwa hiyo instead of writing K, it means that sehemu ambayo kuna K tunaireplace kwa RT. Therefore tutakuja kupata kwamba osmotic pressure V ni sawasawa na nRT. Mwingine pia anaweza kujiuliza hii V N imetoka wapi? So simply tunarudi kama K sasa na RT, maana yake kama kwenye ile question yetu ya osmotic pressure sasa na Km, hatuandiki tena K, tunaandika RT. Kwa hiyo tutakuwa na osmotic pressure ambayo ni ile pi ni sawa na nini? Ni sawa na RT alafu na ile capital letter M. Tunarudi mwanzoni kabisa kwamba capital letter M ni molarity ambayo ni sawa na N over what? Volume. Therefore kama ni N over volume, therefore tukiganya kwa volume kila upande tunakuja kupata osmotic pressure V is equal to nRT. nRT. So this is the formula. Osmotic pressure V sawa na nRT. Osmotic pressure V sawa na nRT. So this is called the Van 't Hoff's equation, which is derived from the Van 't Hoff law of osmotic pressure and is analog to the ideal gas equation ambayo is known as PV is equal to nRT. Sasa ukiona hii equation hapa ya pi V sasa na nRT, this is what known as Van 't Hoff equation ambayo imekuwa derived kutoka kwenye Van 't Hoff law of osmotic pressure. Kwa hiyo hii ndo Van 't Hoff equation. Kwa hiyo hii ndo equation, na hii equation tunaambiwa kwamba this is analog it's analog to the ideal gas equation. Ideal gas equation tunaijua, obviously we are talking about the PV is equal to nRT. Ni equation ambayo inaonyesha the whole all variables of the gas parameter ambayo ni pressure, temperature, volume and the number of mole of gases. That's why unaona kwamba PV is equal to nRT. P ni pressure, V ni volume, N ni number of mole, T ni temperature, lakini hii R ni universal gas constant. Universal gas constant na inajulikana. So my student, you can see that hii equation ina relate na ile that's why tunasema ni analog. It's analogous. Analogous. Kama ushasikia the concept of analogous series, ulisoma kule kwenye organic compound, the way zina mifanano fulani. Zina mifanano fulani. So my student, after there, that is all about the derivation of the what? Of the Van 't Hoff equation. Van 't Hoff equation. Now we can see the Van 't Hoff law of osmotic pressure is related to the gas law that were discussed in the chapter 1. Tuone concept iliyopo kati ya hii Van 't Hoff law of osmotic pressure. How does it relate? Yani tuangalie uhusiano wa hii law, Van 't Hoff law of the osmotic pressure with the relation to the gas laws. Tunapozungumzia gas laws, ndio maana hapa kasema kwamba we are discussed in the chapter 1. Zile tulizodiscuss mwanzoni kabisa kwenye concept za gases. Tulidiscuss kuna gas law, kuna Boyle's law, kuna Charles law, kuna Avogadro's law, kuna combined gas equation law, kuna Dalton law of partial pressure law, kuna Graham's law of effusion and diffusion, na hizo zilikuwa ni kama minors au other laws, lakini mainly tuliona kuna Boyle's, kuna Charles, kuna Avogadro's and so forth. Kwa hiyo utaona kwamba kuna uhusiano uliopo kati ya Van 't Hoff law of osmotic pressure with those gas laws that were discussed in the chapter 1. Anapozungumzia chapter 1 maana yake anazungumzia ile topic ya kwanza kabisa ambayo ilikuwa ni concept ya gases. Kwa hiyo utaona tulisoma kule, lakini tunakuja kuintegrate huku. That way tulianza kule, mean that we start from simple to complex. Tunaanzia kwenye sehemu ambayo ina urahisi, then ndo tunaenda kwenye ugumu. So now you can see that the Van 't Hoff Boyle's law. Sasa tuangalie uhusiano uliopo. Kwa hiyo tuanze na law ya kwanza ambayo ni Boyle's law. Sasa through this Van 't Hoff law of osmotic pressure, mean that tunatakiwa to relate na Boyle's law. Kwa hiyo tuanze na the Van't Hoff Boyle's law. Van't Hoff Boyle's law. So simply the law states that the osmotic pressure ambayo inakuwa expressed by this letter pi of the dilute solution is directly proportional to the molar concentration at the constant temperature or inversely proportional to the volume of the solution provided that temperature and the number of mole remain constant. Kwamba hapa tunajaribu kustate the law. Kama unakumbuka kuhusiana na Boyle's law, tuliona kwamba Boyle's law inaonyesha relationship iliyopo kati ya volume with inversely proportional to the pressure at constant absolute temperature. At constant absolute temperature tuliona kwamba the volume is inversely proportional to the pressure. So tunapokuja kufanya relation na Van't Hoff osmotic pressure, tunaona kwamba the law states that the osmotic pressure, sasa hapa tu consider kule volume of a fixed mass of a gas kwamba ni inversely proportional to the pressure. No, ina maana hapa tunaangalia relation with what? Van't Hoff law of osmotic pressure. So hii statement itabadilika. Kwa hiyo hapa tutakuwa tuna state hii law depending on the Van't Hoff Boyle's law. Tutakuwa tuna state the law depending on the Van't Hoff Boyle's law. So the law states that the osmotic pressure for a dilute solution is directly proportional to the molar concentration. When we talk about molar concentration, simply we are talking about the molarity, capital letter M. The way you see molar concentration. Na maana ni molarity ambayo upo katika molar. But at constant temperature, lakini sometimes it is inversely proportional to the volume of the solution provided that temperature and the number of moles remain constant. So now kutoka kwenye hii statement tunaweza tukaidrive mathematically. So mathematically it will be like this, kwamba osmotic pressure ni directly proportional to what? To molar concentration at constant T. Lakini pia molar concentration ambayo tunajua ni capital letter M ni sawa na number of mole of solute over volume of solution ambayo ni N over V. So you can see that osmotic pressure itakuwa ni inversely proportional to N, I mean ni directly proportional to N, lakini ni inversely proportional to volume. This one at the constant temperature. Or sometimes tunaweza tukaweka hivi kwamba the osmotic pressure is inversely proportional to volume at the constant T and N, at constant T and number of mole. Therefore osmotic pressure itakuwa sasa na K over V, ambapo itakuwa sasa na osmotic pressure volume sawa na K. Sasa if you remember, you can see that the above equation is analog to the Boyle's law. Kama unakumbuka equation ya Boyle's law, kwamba tuliona kwamba Boyle's law V is inversely proportional to pressure. Na ile proportionality tukairemove kwa kuweka K. Ina maana tukapata K ni sasa na V P au PV. Sasa ina maana tukiwa na two set tutakuwa na P1 V1 is equal to P2 V2. Na hiyo ilikuwa ni Boyle's law. So we can able to make the relationship between the Van't Hoff's Van't Hoff law of osmotic pressure with those gas laws. Kwa hiyo umeona kwamba tumeweza kupata equation ya nani ya Boyle's law kwa kuconsider the Van't Hoff law. So that is all about. And my student, you can see that his derivation or his relationship tutaenda kuziangalia katika law zote. Hapa tumeangalia tu law moja ya Boyle's, lakini tutaenda kuona kuhusiana na Charles, lakini pia tutaenda kuhusiana na Avogadro's. Furthermore tutaenda kuangalia the different problems ambazo zinaweza kuwa solved kwa kutumia hizi equation, kwa sababu unatakiwa kutumia hizi equation kusolve maswali mbalimbali. So in A level the most consideration ni wewe kusolve maswali. Kwa hiyo utapitia past papers za kutosha, lakini pia kuna chandi. Tumia ile chandi sometimes imewekwa hadi solution. Kuna hadi majibu pale. Kwa hiyo jaribu kupitia maswali yanayohusiana na relationship za hizi Van't Hoff law of osmotic pressure with the gas laws. Jaribu kupitia maswali mbalimbali ili uweze kujenga uelewa zaidi. And then my student, after there, I would like to say this marks the end of our session for today. Thank you so much for watching our Media Educator TZ. Keep watching our media so as you can benefit from the provided tutorials. Bye bye. I wish you a good time.